Okay, this is the last question in paper 1, and it is a kinematics question. It says particle A starts at the origin and passes through the origin again when t equals p. Find the value of p. So part A, find the value of p. Now, this is the curve of the function, and this is the function. S of t is 8t minus t squared. So t is obviously time, s is displacement. So be very careful, guys. Usually, or often, you get a velocity time graph. This is a displacement time graph. So the y-axis gives you the displacement from the origin. So he starts here, he starts at the origin, and then the further away from the origin this goes, the further away he is from the origin. It's not velocity. So here, this is like his furthest point from the origin so far, and then he comes back to here, and at this point there, he is actually, this is when he passes through the origin again. So that's a little bit confusing because this is the origin, but because it's a displacement time graph, when the displacement is back down to 0, he is passing through the origin again, if that makes sense. So find the value of p. I'm basically trying to find that time here, because the first time he passes through the origin is at the start. I'm trying to find this. And look, this is a quadratic, so I'm essentially trying to find the roots of the quadratic, and in particular, the second root, this root here. So how am I going to do that? I'm going to say 8t minus t squared equals 0. So to find the root, I find where it equals 0. Factorize, I'm going to take out the t. 8 minus t equals 0. So either t equals 0 or 8 minus t equals 0. If 8 minus t equals 0, t is equal to 8. So find the value of p. P is the time when he passes through the origin again, or this point here. So p is equal to 8. Done. Okay, part B. Particle A changes direction when t equals q. Find the value of q. Now, when is he changing direction? If you think of this as a car, think of this this particle. Think of it like a car. So the car is moving away. He's moving further and further. As time goes on, he's moving further and further away from his starting point. I think maybe let's not call it the origin, because that's confusing. So he's moving further and further and further and further away from his starting point. But as soon as he crosses here, now he starts coming back to his starting point. Back to his starting point. And here he reaches his starting point again. And then he's actually going backwards. So he's going away from his starting point, but in the other direction. So when does he first change direction? Or when does he, the only time he changes direction is right here. It's at that maximum. That's when he changes direction. So I need to find the coordinates of the maximum. Now there's a number of ways to do this. I could just do the minus b over 2a formula, or I could just find the derivative. So I prefer the derivative. Let's find where the first derivative, s dash of t, is equal to 0. S dash of t is equal to 8 minus 2t. That's the derivative of this. 8 minus 2 times 2, bring down the power. 8 minus 2t equals 0, 2t equals 8, t is equal to 4. Now that's the derivative. Also, in fact, this is probably the easier way to do it. It's going to be, because it's a quadratic, it's going to be exactly halfway between these two. It's going to be halfway between 0 and 8, so t is equal to 4 is definitely the right answer. But that's a nice way to, knowing how to do it both ways is both useful for your understanding, but also to make sure you're correct. Okay, this was B part I. And then the second part of B, he says, find the displacement of A from the origin when t equals q. Okay, so we want the displacement of A from the origin when t equals q. So this gives us the displacement for any t. So I just want to find the displacement for t is equal to 4. So s of 4 is going to equal 8 times 4 minus 4 squared, which is 32. 32 minus 16, which is equal to 16. Does it give me meters or anything like that? No. So S of 4, the displacement of A from the origin when t equals q, which is 4, S of 4 equals 16. And that's the answer. This is the answer for BI, and this is the answer for part A. Okay, I'll do part C in the next video.